Hello students, in this session we will discuss about solving a numerical to design a constant K low pass filter. So let's take this numerical into consideration. So it says design a constant K low pass filter network having cutoff frequency 1 kHz and design impedance 400 ohm. So let's start solving such a numerical to design a constant K low pass filter. So look at this. So see, the given things are the cutoff frequency equal to 1 kHz or 1000 Hz, which is represented as FC, and then the value of design impedance is 400 ohm, which can be noted as R0 is equal to 400 ohm. So once we know these two given values, we can use the formula to find inductance L equal to R0 upon 4 upon pi FC, and we get the value of inductance to be 127.39 millihenry in this case. So once we obtain the value of inductance L, we can obtain the value of capacitance C by using the formula C is equal to 1 upon pi R0 FC. So if we substitute the given values of R0 and FC, we get the values of C as 0.796 microfarad and value of inductance as 127.39 millihenry. Now see, this is a designed low pass filter of the T symmetrical type, wherein the quantities to be written are to be written very carefully. Look at this. So a low pass T symmetrical network consists of a series arm impedance involving two inductors and a shunt arm impedance involving a single capacitor. So the value of capacitor will be equal to the value that you have found out, that is capacitance value C is equal to 0.796 microfarad, and the total series arm inductance is found to be 127.39 millihenry, but a series arm impedance is to be a series combination of two inductors. So when two inductors are kept in series, the equivalent inductance should be 127.39 millihenry, and it is possible only when 63.695 millihenry of an inductance is connected with in series with another inductor of the value 63.695 millihenry. That is, I mean to say, half of this inductance should be represented as one inductor and half of this inductance should be represented as another inductor, and they are acting in series with each other, so they together form a series arm impedance. So this is how you designed a low pass T type of symmetrical network low pass filter. When we talk about designing a high pass filter, a low pass filter of the pi kind or pi type, this is the usual configuration. The configuration consists of one inductor in the series arm and two capacitors in the shunt arm. So one inductor in series arm obviously should be of the value 127.39 millihenry, but two capacitors are to be connected in to form a shunt arm. So when two capacitors representing an equivalent shunt arm should be equal to 0.796 microfarad, this is possible only when 0.398 microfarad of one capacitor and 0.398 microfarad of another capacitor are connected in shunt with each other. So ultimately it means a C by 2 capacitor should be connected in one branch, a C by 2 capacitor should be connected in another branch. So when two capacitors we know are when connected in parallel, then the equivalent capacitance is addition of the two. So C by 2 plus C by 2 will be equal to the found out value C. So keep this in mind. C by 2 plus C by 2 will become equal to C in case of capacitors when they are in parallel, or when they represent the shunt arm branch. So this completes your solution to design a constant K low pass filter if is asked in the examination. Usually every year one such numerical of 6 marks appear in the examination. So I hope you understood how to do this. Thank you.